Welcome back. In this video, we're going to talk about using percentages to take discounts or add increases. Percentages are useful for calculating discounts when prices or other quantities go down. They are equally useful for calculating what happens when percent increases are applied to prices or other quantities. So when prices or other quantities go up, percents are useful. Discounts are probably more common, at least in general usage, so we're going to start there. Discounts are often expressed in percentage terms. For example, stores and online retailers commonly advertise sales using percentages, as in 25% off pasta this week, or use coupon code SALE35 to take 35% off at checkout. These percent discounts are applied to the original price or total. So in the case of the pasta, the 25% would come off of the original price. In the case of the coupon code at checkout, the 35% would come off of the total purchased in that shopping cart. Taking a look at example 4.11, a local deli is offering cheddar cheese slices at a 20% discount. The original price was $7.99 per pound. What is the sale price per pound for this cheese? Round the answer to the nearest cent. So remember, the nearest cent is the hundredths place. The original price was $7.99 per pound, and we want to apply this 20% discount to that. There are a couple ways to go about this. One is to simply calculate how much 20% of 7.99 is, and then subtract that amount from 7.99. So one way we can approach this is to figure out the amount of the discount and then subtract that amount from the original price. If we were to do this 20%, remember, is 20 over 100, which equals 0.20, so that's the percentage we will use in our calculation, multiplied by $7.99 a pound will give you 20% of $7.99. This is using formula 4-1. So we take our percentage, 0.20, multiply it by the original amount, $7.99. That's the original price in this case. And we find that the discount, rounded to the nearest cent, is going to be $1.60. That comes out actually to 1.598. We are rounding to the nearest cent, so we need to round up the 9 in the hundredths place based on the fact that the third decimal place has an 8, which is more than 5. That 9 rounds up to a 10, which means 1 has to be added to the 5 to make $1.60. If that does not seem comfortable to you, return to the rounding video because there are a couple examples of 9s in the round to digit place. In any case, this is step 1 of the way that we wrote out here, the little algorithm to solve this problem. Step 2, subtract that amount from the original price. The original price was $7.99. $7.99 minus $1.60 comes to $6.39 per pound. Another way is to figure out the remaining percentage that should be left over after the discount. And then calculate that percentage of the original price. First step, figure out remaining percentage after the discount. Well, there's 100% total. We want to take a 20% discount, so we subtract 20% off of that, and we get 80%. In step 2, we're going to want to calculate that percentage of the original price. So using 80% with formula 4-1 to calculate the percentage, we move that decimal on the 80 over twice to get 0.80. I'm putting the 0 on there. It does not need to be there. You could just write it 0.8 since there's nothing non-zero after the 8. And that gives us our mathematical percentage, which we multiply by $7.99. 0.80 times $7.99, which is that original price. And you get 6.392, which rounds to the nearest cent to 6.39, which is the exact same answer, of course. because that's the way percentages work. So either way you want to do this, you can do it. Discounts are used in supply chain management and other aspects of business that involve repeat ordering from suppliers. Let's take a look at a typical example in example 4.12. A manufacturer placed monthly orders with a supplier. Last month, the manufacturer ordered 438 parts. Due to a forecasted decrease in demand, the manufacturer decided to cut orders from the supplier by 30% this month. How many parts will the manufacturer order? The original amounts, the amount that they ordered last month is 438 parts, and we want to decrease that amount by 30%. Following those algorithms I wrote out in example 4.11, let's do this both ways. One way is to figure out that 30%, which is 0.30 times 438, is 131.4 parts. Now you see this came out with a digit after the decimal point, which is 4, and we know we can't order 0.4 parts, but let's wait until the end of the calculation to figure out what we are going to order. So now we've figured out that 30% of 438 is 131.4. Now we take the total amount of parts, that is the number we ordered last month, we subtract the 131.4 that we want to not order this month, and we get 306.6. And this would just get rounded to the nearest whole number because you have to order whole numbers of parts. Because the 6 in the tenths place is 5 or more, the 6 in the ones place needs to be rounded up to a 7. Let's go ahead and do this problem the other way. First thing in the second algorithm is to figure out the remaining percentage after the discount. So 100% is the total price minus 30% equals 70%. So 70% of the price should remain after the 30% discount is taken. The way to calculate that is to simply calculate 70% of 438, which comes out to 306.6, which once again should be rounded to a whole number since these are parts we're talking about, and we should order 307 parts. Which method should you use? Whichever one makes the most sense to you. Finally, percentages can be used to calculate increases as well as discounts. Interest applied to loans is a good example. When interest is charged on a loan, it means that the person has to pay back the original amount plus the amount of the interest added on top. So they have to pay back 100% of the loan plus the percentage of interest. Taking a look at example 4.13, a person took out a loan for $6,225 with terms that they will repay the money in 1 year at 4% interest. How much does this person owe at the end of the year? So as applied to this example, the first thing you do is figure out the dollar amount of interest that this person owes at the end of the year, and then add that to the total amount. If this was not dollars, we would just figure out the percent of whatever amount we were talking about, and then add it to the total amount. So 4% interest is 4 out of 100, and that equals 0.04. So notice there's that 4 is in the second decimal place after the decimal point. To figure out the dollar amount of interest, we take 4% of $6,225, which comes to exactly $249. In step 2, we add that amount to the total amount. Total amount of the loan was $6,225 plus $249 in interest, and you get $6,474. Another way is to figure out the percentage first, and then use that percentage to calculate this increased amount. So figure out the percent that is owed at the end of the year, and then calculate that percent of $6,225, which is the total amount. So to do the problem this way, the percent owed at the end of the year is all of the money that they borrowed to begin with, which would be 100%, plus the 4% interest. So the amount owed at the end of the year would be 104%. We know expressed as a mathematical percentage, 104% is going to be 104 divided by 100, which equals 1.04. So we can use that to calculate the percentage of the total amount. 1.04 times 6,225 comes to 6,474. So that's the exact same amount that we got before, because we're just doing the math a little bit differently, but it's the same math in a different order.